Hello guys, I'm audible. Hello guys, welcome to my YouTube channel, Yojana Regni. I'm Yojana Regni, and today we're not going to bring any of the drawing videos or the travel related videos. Today I'm going to be presenting a short presentation that I had done when I was back in college. Okay, this was like 2 years ago, and I found it in my file section while I was going through, cleaning up my laptop, and I thought, why not share it to you so that you can understand what I'm going to talk about. If you have any problem, you can always comment it, or you can also Google, okay? Because there might be some gaps, which I'm telling you. Okay, Mm, okay, okay. I'm sorry. So there might be some gaps. The techniques that I'm presenting, there might be something which is missing. So I'm very sorry for that. Okay. This was when I was back in college. I already said that. But this is not a field that I'm directly involved in. Okay. This is based on the learnings from the books and the internet, of course. And as an electrical engineer, this is obviously related to electrical engineering. So the topic that I'm going to be telling you right now is live line working. Okay, what is live line working? Before that, we're going to tell the things. So, what are the things that I'm going to be talking about in this video? Is the definition of live line working, the importance of live line working, the history of live line working, live line in different scenarios, the methods which we do live line, the existing practices in our country or in other countries, yeah, the benefits of live line working, and the precaution that you have to take when you're doing any work which is live line working. So what is live line working? I'm going to drop it here. Sorry for this webcam. Okay. Live line working is the maintenance of electrical equipment which is usually at high voltage when the equipment is still energized. So you see in our day-to-day life what happens is we we will do some repairing works with an electrical equipment. But before that, we are going to turn off the supply to it, and then we're going to open the screws and we're going to look at the connection, use a tester or so, okay? While the system, while the equipment is not getting supplied by electricity. But live line working is different, okay? In live line working, what happens is the equipment is still getting supplied, and we're going to, see where there are problems. It is very dangerous for the worker in comparison to deenergized line. It is dangerous only if the worker is not using the tools and the gloves and other stuff that is needed while they are working. Okay, so I can't believe I'm telling you, but don't try this at home that you're going to see what is the live line working and you're going to open an electrical equipment while this connection is being still supplied. Okay, it's very dangerous. It is usually done at high voltage in the presence of the professional and engineers. Okay, so it is used to perform periodic maintenance on transmission lines to avoid disruption and high economic cost of having to turn off the power to the consumers. So this is one importance, live line working. Okay, we have to go to the importance of live line working. So I'm going to explain it a bit more. So if you have radial lines, if there are increasing consumer demand, if there is a lack of new power line construction, and if you want to reduce risk and minimize the cost, we're going to need live line working. Okay, I'll be explaining a little bit on this. Okay, radial lines. What is radial lines? Okay, as a layman terms, I'm going to be explaining it as clearly as possible. Radial lines mean, suppose I am a consumer. I'm getting supplied from this direction, from this lines, transmission line, distribution lines, whatever, okay? I'm getting supply from this line. If I'm only getting supply from this line, this is called radial line. But what happens is there are sometimes other lines, in the case of a ring network, that if this supply is off, I'm still getting supply, electricity supply from this side. Okay, this is called a ring system. But if I don't have this side of supply, I'm not if I don't have the connection or the wires connecting me to the source through this part, I have only one type of, if I have only one line, then this is called radial lines. So I have to do some maintenance work in these lines, and I cannot do a load sharing with this consumer, okay, with me, okay. So if the electric power company has to work on this line and they cannot risk getting, the consumer shut down, then they have to work live line, okay. That is obvious. If there is increasing consumer demand, if there are lots of consumer demand, then they cannot risk doing shutdowns for every maintenance stuffs, okay. The third is lack of new power line construction. For example, a consumer is here, they are getting supply from this line, but there is also a redundant or a parallel line running across the street or somewhere, and they can use these lines, the another lines to supply power to me. They have to do the shutdown. But if there is no such lines, if there are no power line construction, then they have to work live line on a notice, on a demand, or on a condition that I do not have to be shut down, basically. It reduces the risk and minimize the cost. So how is cost minimized? Because we're going to do periodic maintenance. So it will tell us about the unforeseeable circumstances that may arise. We can see the weak areas in the transmission line, the conductors that may get deteriorated over time, and we can replace them on time, which can help us to minimize the cost. Okay, let's start with the history of live line working. Okay, it started from the early years of 20th century. In 1960, it started that the field workers were able to directly touch. Okay, they were able to contact. They were able to come into direct contact with this high voltage line. Okay, so it was until in 1980 that we could use helicopters for aerial work. Okay, this was done to replace the spacers in the transmission lines. Okay, it was basically it started as an emergency response to the line outages. The webcam is in the path of this presentation. So okay, back to it. The emergency response. In emergency response, it was used. The liveline working was used for maintenance, conductor support, and so on. In different scenarios, in different fields where our lifeline working used. In condition monitoring, in transmission line, in extra high voltage switch yards, in insulator washing, and in distribution lines. I'm sure there are a lot of different scenarios, but these are the ones that I've summarized for some examples. Okay, I'm going to be explaining them one by one. In condition monitoring. So what does monitoring mean? So we're going to see the condition of the equipment. So I have taken an example of an insulator here. In insulator, there will be punctures, okay? There can be punctures, not that there will be, there can be punctures, okay? So the internal puncture phenomenon, they cannot be recognized by inspection of the equipment visually. We cannot see them. If we take an insulator, we cannot know that internally there may be some puncture or the cracks in the insulators, okay? And we have to know whether there is puncture so that we can replace the insulator with a better working one. So for this, we use a special microprocessor based device which is called puncture insulator detector, where what happens is that they will identify any electric field. They will determine the electric field which is surrounding the insulator, because when the insulator is connected through the line, obviously insulator will not pass the electric current through it, but there will be some electric field that will be surrounding the lines. So they will determine those electric field, and they will give the analog input to the digital form, and that digital output will be analyzed by the qualified engineers. Okay, this is done for every type of insulator such as porcelain, glass, or even polymer insulators. They're used for different types of lines and switch yards. Obviously, in switch yards, you will have this insulator. In transmission lines, also, there are insulators. Okay, so this is one example of insulators where we monitor the condition of the system while it is still being energized, while they are still getting supplied electricity. Other condition monitoring techniques will include fault passage indicators for distribution lines, inspection of energized electrical joints and line conductors. So there will be joints, and we're going to identify whether there is any electricity flowing through the joints or there are like energized electrical joints. We will use this thing in the live line working as well. Live line working on transmission line. Okay. So in transmission lines, which is on high voltage, like more than 33 kilovolt in Nepal, I'm sure it is sub transmission line starts from 33 kilovolts and above. We use it for routine maintenance activities. Okay. On transmission lines, transmission towers, we use live line working for insulator replacement on suspension and tension towers. So these are the two categories of towers, and there are like insulators stacked, okay, one upon another. So we use this technique. We use live line working while we are going to replace the insulator because, like, get a scenario. Like, let's think of a scenario that if you're going to replace an insulator, we cannot shut down the entire transmission line connecting from one area to another area. We cannot shut down the electricity because there may be a critical path. That may be a critical path as well. Okay. Another thing is we can also use the live line working to tighten the clamps and the connectors. Okay, this is basically routine type of maintenance activities. Okay, we can use it to strengthen the dead end joints. We can replace the jumpers and the mid-span joints. We can do line conductor repairs, insulator hardware maintenance or replacement. Okay, these are the areas where we can do some routine maintenance while they are still energized. Specially designed conductor trolleys for bare hand techniques are used to work on energized conductors with increased safety and efficiency. So there is one technique which I'm going to be explaining in the later part of the video or later part of the slide. The technique is called bare hand technique, which uses some trolleys so that we can work on energized conductors. Okay. Okay. So the third, I think this is the third thing, is the EHV switchyard, which is extra high voltage switchyards, which where we can do the maintenance activities up to 765 kilovolts. As you see on this picture, this is a like special equipments. It's called a modular scaffolding system where the operator, the people, field workers can use it to do some various maintenance activities such as, we can replace the jumpers or rectify some hotspot, isolator switches, because in switchyard obviously we have insulator isolators. Okay, there are so many types of isolators such as, center break, center rotating, so many. So we can maintain them. We can tighten the clamps and connectors. Bus bar tubes can be replaced, and even lightning arresters. Okay, the lightning arrestor, we can replace them. Okay, this is, and we can work on high voltage line traps with on-load temporary bypass switch. Heavy support insulator can be replaced with specially insulated forklift attachment. So there are a lot of equipments we can use while we are still working on switchyards while they are being still energized. Now this is the thing called live line insulator washing. Okay, this is an exciting part for me. Is like, why do we need to wash the insulator? Like, insulator is a non-conducting device, obviously, and you can see there is a transmission tower, and then there is this insulator. This is stacked one up another. So this is clearly a suspension type of insulator, suspension type of transmission tower, and there are like conductors which is connected to the end, and it is supplying the it is not supplying, it is actually holding the conductor. Okay, so insulator washing. Okay, usually if you see that if you are in a coastal area, then the air surrounding you will be a bit they will be full of like salt. Okay? The salt deposits will be there on the insulators which are near the coastal areas such as sea or the oceans. Okay, the air molecules will have some concentration of salt, and over time they will get deposited on the surface. Or in the industrial area, there will be dust, smokes, and various other pollutants which will be in the environment, and they will settle on these insulators. So what happens is that due to these pollutants, there will be a insulator flashover, which is very costly. In insulator flashover, what happens is that with these pollutants, the electricity will be able to pass through them, and there will be, flashover that will damage the insulator, and we have to replace the insulator, so it is very costly. Okay, so we use a special device called twin high pressure jet washing guns, which is available up to 800 kilovolt lines. You can see on the picture as well, a person is on the helicopter, and then they are using the special equipments and throwing the water on the insulator, and they're washing away the pollutants. So according to the study also, it has been shown that the leakage current will be reduced by 40% if you use the jet washing techniques. This is one benefit. So this is one scenario where we use live line working. On distribution lines also, we talked about transmission lines, we talked about switch yards, we talked about condition monitoring, we talked about insulator washing. Also on distribution lines, which is in Nepal, it is like 33 kilovolt and less. Okay, we can use live line working. So sometimes we don't want to do load sharing. Okay, for that, but maintain we have to do some maintenance work, repairing works. Then we can use live line technique using special techniques, like you can see the rubber glove technique. We can use aerial work platform. We can change the pin or the disc insulator. Usually these are the insulators in distribution lines. We can rectify some hotspot. We can repair some conductors and jumpers. We can trim the trees. Usually there is some routine activities for distribution line that the trees, if they fall on the lines, then they will cause a fault. Okay, there will be interruption in the supply. Okay, so we have to regularly trim the tree branches so that they don't come in contact with the lines, because usually the distribution lines, they are not cover conductors. Some might be, there might be, not always that you will get a cover conductor type of lines. So for that we can use tree trimming. Okay, and we can even replace a pole in the energized condition. But obviously there are some techniques, you have to follow some regulations to do all these examples, to all do all these stuffs. But there are some scenarios we're not going to use a live line working. For example, we're not going to use it on climbing inspection, conductor stringing, the hardware tightening, the holding, pole setting. So there are like not everywhere that we can use the live line working. Now this is the topic of methods. The methods which we can do, the methods where we can do live line working. So there are three. These are insulated stick, the glove method, the bare hands method. Okay, insulated stick method. I'm going to place it in here. Okay, so sticks. You can see on the picture, this field worker is using a stick, maintaining some distance between him and these lines. Usually, what happened was, in the previous days, this stick used to be of wooden ones. Okay, they used to be of baked woods, and now it is made of fibers. Okay, the glass sticks, we use it now. This is in common practice. It is suitable up to 220 kilovolts. Now, what happens is that this stick will provide the insulation between this line and the worker, so that the person will not be in direct contact to this line and will not get a shock. Okay, so the worker has to remain at a specified distance. Okay, that it's not that a worker can come very close to the line and then with the help of just a stick they can do work. No, you have to maintain some distance, which is prescribed by the agency. I think it is prescribed. There are some specification based on the kilovolts that you're working, the distance you have to maintain. So this is insulated stick method. Rubber glove or contact method. So based on the name, you can see the person will be using some rubber. Okay, and the contact method, first point of contact, second point of contact. I don't know where I'm going to keep the webcam. Okay, the person will be fully insulated from the ground through an insulated elevated platform and perform the live line work using approved insulating gloves and sleeves. Okay, in this contact method, there are like first point of contact and the second point of contact. Let's explain what does that mean. Okay, when a person is using the gloves and they are working with the live line, they are working with the conductors and the staffs, through their hands, the electricity, the current will pass through it. But gloves will be there, the insulating gloves will be there, and they will not be able to pass the electricity to the person. So this is the first point of contact. Like the person is touching the gloves. Sorry, the person is touching the wire through their hands, and there is the glove. So this is the first point of contact. Now, the second point of contact is the blankets and the line hose that the worker will use, so that even if there is a current passing through him, they will not be leaving the body, because like if a current leaves through a body, then the circuit is complete and then the person will get shocked. Okay, that will be avoided by use of blankets and the line hose. It is used for work above 1 kilovolt AC and 1.5 kilovolt DC. It is useful for only distribution networks up to 46 kilovolt. In Nepal, we don't have 46 kilovolt of distribution lines. FYI. The third is the bare hand technique. Okay, this was used in 1960, the beginning of the time when the person were able to contact with the live line, the starting point of the live line working, which was used from that beginning also. Here what happens is the live line, the lineman usually will be in direct contact with the live parts, and the lineman will be insulated from the grounded objects. So we are using helicopters in this case. Okay, the worker will be working alongside the lines from a platform that is suspended from them, or they may sit directly on the line itself. Usually, if you see some videos in some photos where person will be sitting on the transmission lines and they are working, okay. Or another thing is they can be suspended from a platform which is grounded, which is not touching the ground, which is not letting the current pass through them or complete the circuit of the current. They are not letting it, so they are using some aerial stuffs. So before the person is in contact with the lines, the person has to be raised to the same electric potential as the live parts. So this is a different technique, because in the previous technique, if you remember, what happened was that the workers, the operators in the field will not be touching the lines directly. They will be insulated from it. Here they will be insulated from the ground, okay, but they will be touching, they will be on the same potential as the line. Okay, some, for example, the electric potential of the line would be, for example, at 132 kilovolts. Then the person who is working will also be of the same potential, and then they will be held together by the electrical connection. You can see this wire which is coming from the lineman's body, and it is connecting them so that they are always on the same potential while they are doing or maintenance, while they are working on the lines. Okay, but they are making a suitable isolation. Okay, they are on the helicopter, they are just suspended, they are suspended from the ground. So this is like they are suitable, that they are on the isolation from the surroundings. Okay, so you use helicopters or any insulating ladder to work on live parts. Now, this thing is called, as I've said, they have to be on the same electric potential. So how does the person approach the same electric potential as a line? For example, if you touch the line directly, there will be arc forming, as you can see. But if you get the arc from this hand to the line, then the arc will damage the body. So we're going to use a whip like structure, and then the lineman will be coming closer, and then there will be arc forming, and the lineman will close the gap, and then they will touch the line. So now they are on the same potential, but now they will also use these type of clamps so that they are always in the same connection. Because sometimes what happens that if they are not always connected, then while they are like leaving the hands, leaving while they are not touching the wires and again touching, then there will be arc forming if they are on different potential. So they have to maintain the potential always. So this is how they start, and this is how they continue to work. So as you can see, the arc will form between them when the worker gets charged. This arc can have adverse effect on the worker's health, so he has to bond immediately to the electrical line, okay, to prevent further arcing. So this is a special Faraday suit. Okay, you can see the suit that they are wearing is different. So this is made up of conducting fibers. Now you're saying, why are we not using any insulating stuff? But we are using a conducting fibers. We are using it so that the electrical potential will be evenly distributed. Because if there are uneven electric potential through his body, for example, through this point to through this point, there may be some different potential, then the current will pass, and he will get a shock. So he has to maintain equal potential. So this will be made of conducting fibers which will equalize the potential, and it will be safe for the workers. So this is called a special Faraday suit. It is used above 132 kilovolt and up to 1150 kilovolt in Russia. Used in Russia. Okay, so 132 kilovolt is usually the transmission line voltage. So in existing practices across the world where we have done it, in Nepal, I don't think we have done any live line working, but in India, Russia, China, electricity reliability is very important. because it is a economic country and the population is also high, so they cannot risk, or they cannot do the shutdown of the consumer while they are working on every line. And it's a big country, so in the case of India, they had used the live line techniques. They have still been using. They have used since 1960. They started with the hot sticks up to 220 kilovolts, and with the help of the bare hand techniques, now we can see we can also do work on the 400 kilovolt lines. With the introduction of modular scaffolding system and puncture isolator detectors, which was used in condition monitoring, live line technology had a boost. Okay, it was since 2005, and currently it extends up to 765 with insulated aerial work. Russia had done in 115 kilovolt. Okay, in September 24, 2020. So this was the recent news at the time while I was going through this, uh, working on this research, that that a Chinese company, a corporation, State Grid Corporation of China, had completed its first, or the world's first, mountainous online maintenance task and repaired a line while still being while still being supplying the electricity to the consumer. So what are the benefits of live line working? First is uninterrupted and timely maintenance. Okay, we don't have to shut down the consumer, and we can do the maintenance frequently. We don't have to make excuses that we're not getting shut down for this work. We can increase the reliability of the system. Obviously, efficiency increases, the maintenance cost will be reduced, operating cost will be reduced, because the more we are using these type of techniques, the more we are going to keep the system operating. Okay, the system will be healthy, so it is beneficial. We are going to tackle with the unforeseeable circumstances also. It increases the safety of operations, which is, if you think about it, in live line working, you have to work with special suits and equipment, so there will be safety. What happens is, in de-energized line, if you can hear a lot of cases that a person will be working, but somehow the electricity supply will be getting back on, and the person will get a shock, and unfortunately they will lose their lives. But in the live line working, you already have a electricity connection, so in that case, you are already prepared. You already come with tools and equipments. Okay, the maintenance of the continuity of service to the consumer, which is uninterrupted supply, early attention to system problems. Uh, Now, based on the factual data, we can see that in research which is done by Dominion Power Company, which had some 260 structures. Okay, so they found out that when they use the aerial service for inspection and maintenance activities, their cost was saved up to 67%, and the time was reduced up to 99%. So this is the factual data, which is very useful for people to adopt live line working. So it's very beneficial based on the cost as well as the time. Okay. So general precautions. Okay, you have to. It's not that it's always safe. Okay, you have to maintain some precautions, as there is a golden rule called nothing is too safe when a life is at stake. Obviously, so the records show that live line work on high voltage line is safer than maintenance work on cold lines. Cold lines means de-energized line, which could possibly become energized while the line is being worked. As I already told you, sometimes they will be working, and suddenly electrical supply will be there, and they will get a shock. So that is the disadvantage. But if you work on live line, you're already prepared. Okay? The calculation of minimum approach distance take account for the switching surges and other transients. So you have to maintain a distance when you're using hot stick method. You have to maintain some distance which is based on the voltage. Okay. The protection against unplanned over voltage events such as switching surges can be provided by means of device such as portable protective air gap. Okay. This is a bit, we can explain further in this, but I don't think I have the time and the slides needed to explain it. Okay. Moving on, the electric arc. Okay, you know the arc when we are doing with the bare hand technique. The arc was there when you are going to approach a line. There will be arc, and that arc will cause an arc eye. It is a very painful and potentially blinding condition. So to prevent that, The linemen or the workers are provided with tinted goggles to protect if there is a flash or even if there are some like debris which is ejected by the arc, because sometimes there may be like some pollutants or things and the arc will throw it in your face, in your eyes, and cause an arc eye. So we use some goggles. Okay. The next thing is to prevent the workers from getting exposure to these electric fields. There is some limits. Okay, so there will the IC and IRP. Okay, in the UK, this is a national grid. It has imposed a limit on the current in the conductors while the lifeline is in progress. Okay, it is based on the numerical dosimetry. And if you explain more on that, there are like some tables which shows the exposure that the person is safe to work on. Beyond that current, okay, we are not going to work. So these are the some general precautions. So these are the reference I had to look for. Okay, this helped me to put up some informations in these slides. So thank you very much. If you have some queries or doubts, you can comment on this video or you can even search it. And this was a very old video of mine, so I'm sorry if I forgot some of the points, because I'm sure I had a lot of points which was not summarized, which was not presented in points in here. But in and all, if you found this video helpful, please give it a thumbs up, and we'll see you in the next video if I'm going to present any of these. So thank you.